Hi everyone, in this video I want to talk about graphing quadratic functions in intercept or factored form. Here are the two problems that we'll do, and to make sure that we don't take ourselves too seriously, let's think about the fun question. If you had the opportunity to live in Antarctica for a year with all of the proper gear, would you take it? So on the math section, you will see quadratics, I'm sure, in some shape or form. There could be questions about the graphs of the quadratics, the shape of the parabola and where it might hit the x or y axis. And so this intercept or factored form, I think, is the easiest of all three. The two other forms that you could see are vertex form and standard form, and I do have videos on those too as well. Right here, this is already factored for us. So what we can do is figure out, remember that roots, zeros, and x-intercepts are all the same thing. So if we find, let's say, the x-intercept, the x-intercept is where it'll hit the x-axis. The y-intercept is where it'll hit the y-axis. We can set y equal to 0 and solve x here. We can set x equal to 0 and solve y here. So, okay, if I have 0 equals and then -3 times x minus 1 plus 5. Okay, I'm thinking about if 0 is equal to this whole product, then at least one of these pieces must be 0, right? We know it's not this first one, it's -3. But this whole entity here could be 0, this whole entity here could be 0. So I better set y or x minus 1 equal to 0 and x plus 5 equal to 0 and solve for x. I get either, so if I add 1 on both sides here, I'd get x is 1. I would get x is -5. Notice I don't really set this -3 equal to 0 because it won't give us an answer. It'll be like no solution. So what we're trying to figure out is just what would the two variables equal. Then I can graph those. So we have 1. That's where it's hitting the x-axis. Remember the intercept? That's at 1, 0, and then -5, 0 here. Now I know that we could somehow figure out a y-intercept, okay? That's if I set x equal to 0 and solve for y. So that would be y equals -3, 0 minus 1, 0 plus 5. That point might help us. We'll get -3 times -1 times 5. That is y equals 15. Okay, so that's helpful to know that it's up here somewhere. But what we have to figure out really that's the most helpful is the axis of symmetry and where the vertex is. So you're always kind of fishing for the vertex. So we'll call this y-intercept fairly helpful. Starting with the intercepts is a great way to go up about these problems. But we do not know where the vertex is, and that's a really important piece to the shape. One thing I do know is that this A part is negative, so I know the graph is going to be pointing downwards. Okay, so now we have our intercepts, but really, I want to figure out where is the vertex, somewhere along this line, right? Well, if I take the 1 and -5 and I average them, I get -4/2, which is -2. Okay, so the axis of symmetry must be there. Let me go ahead and box everything here. So I always want to stay very neat and organized so that everything pops out at me nicely. So -2 is where our axis of symmetry will be. that is the mirror line that will cut the graph in half. Okay, so then I know that this, we'll call this an X, that is going to be where the vertex is on the X. So -2, it's got to be along the line, -2 somewhere. But the problem is we don't know where the Y is. So how do you figure out the Y? We'll say plug in -2, solve for Y. Okay, so that's going to go into the X up top. So we're going to get Y equals -3, and then we get -2 minus 1, -2 plus 5, and we get Y equals -3 times -3 times 3. Ah, so Y is 27. Okay, so that point is going to be way up high in the sky here. In fact, it's so far up there that I am actually not going to be able to draw it. So I'm going to just sneak it right here. And I do know that the y-intercept is at 15, so it's almost like it's kind of falling right here. But sometimes your graph isn't going to look just perfect. So just know that this graph is, it's going to be, if I really drew it correctly, it'd be like way up here. So we will draw a shortened version of it like this. It's very elongated. And of course, pointing downwards because we have a -3 on the outside. Now, in this second problem, when we take each, when we're trying to find the intercepts, we're going to set the 0 equal to both binomials. And I'm going to go 2x plus 3 equals 0. And then x minus 4 equals 0. This one, I'm just doing quick math. X equals 4, right? This one I need to take it slowly and make sure I don't mess up any negatives. So that x is not going to hit at a nice, happy integer number. Positive 2. This is basically -1.5. So then what you do is you'd plot the 4, and yes, this can be a fraction, -1.5. So what's the middle point between the two? So this is axis of symmetry. That's going to be the average of those two numbers. So -1.5 plus 4 over 2. Okay, so that's 2.5 over 2, which is 1.25. Okay, so that means 1 and a little bit after, that would be the axis of symmetry. You can kind of look at your graph and make sure it makes sense, and it does. So what I want to do now is think about where could that vertex be. So we know that it's going to be 1.25, and then I'm going to plug everything else in. So we're trying to find the y. So we're going to go y equals, and then 2 times 1.25 plus 3, 1.25 minus 4, y equals, and then this will be 2.5 plus 3, and then this is -2 and 2.75. Okay, so y equals, and then 5.5, -2.75, that's negative. And then this is where we want to check with our calculator. So we know it's going to be negative, and it's, so that means it's going to be, over 1.25, but then pretty far down. So 5.5 times -2.75 is -15.125. Okay, -15.125. So we'll call it that, but then just kind of approximate. So now that means that the vertex is, both of those together. So 1.25 and -15, like way down here. This is going to be pointing upwards because I can tell because this A term would be positive. There's no negative outside. So we have some pretty extreme graphs here. One is, they're very long. One is pointing downwards, one is pointing upwards, but they, kind of ran off the graph, in which case you kind of draw your point and approximate. So just to follow back on this is 2, 27. That would be the vertex for that one. Okay, so try a couple practice problems. They are very similar. Notice one is positive, has a positive A, and the other one has a negative A. And remember that, the axis of symmetry is that midline between the two intercepts, and the vertex is what you really are trying to find in the end. So see how far you can get. Why don't you pause the video and I will reveal the answers. Okay, here are the answers. What's funny about these is they have the same intercepts, -1, -3, -1, -3, but the graphs are very different. So one is pointing downwards, one is pointing upwards, and when you average out that axis of symmetry line, between the two, you get -2 for both. So you'd plug -2 in to each equation and see which y you would get. For this first one, you end up getting 1, and then this y, you end up getting -2. Let's give you a quote to keep you going. So don't confuse comfort with happiness. That's something that I think about a lot. I think this is really good food for thought. So I hope this video helped you in some way. And if you'd like to leave the answer to the fun question in the comments, that would be great. And feel free to subscribe if you'd like to keep up with new videos. Thank you.